Whether you are looking for a new experiment to support your science curriculum or looking for ways to integrate computational thinking, PASCO is here to help. In 2019, Code.org released a report on the state of computer science education. As of 2019, 34 states have adopted computer science standards, and many now hold requirements for completion of a computer science course for graduation. Additionally, states such as Florida now offer computer science courses starting at kindergarten. Computational thinking and coding are parts of the larger picture that make up the computer science standards. Now more than ever, computational thinking is taking center stage. The idea behind this stems from how rapidly our world is evolving with the use of technology. Can you imagine your world without your cell phone? Computational thinking is the ability to put critical thinking skills into action, as well as being able to connect digitally. It is the ability to think and act like a computer scientist. It doesn't mean we're all going to be computer scientists, but we can take these skills into other fields such as medicine and engineering and come up with new innovations that make life better. We can break up the process of computational thinking into 4 parts: decomposition, pattern recognition, abstraction, and algorithmic thinking. So what exactly does each step mean in this process? Decomposition is breaking down of complex problems into smaller ones. Pattern recognition is looking for similarities. Abstraction, filtering out what is most important. And algorithmic thinking, constructing a step-by-step process for solving the problem so work can be replicable. When you think about it, students and teachers practice computational thinking daily, but it helps to make it explicit by giving some more detailed examples. For example, decomposition could be students researching organs of the human body to understand how the respiratory system works. An example of pattern recognition is keeping a food diary to assess what makes your stomach upset. Abstraction could be conducting a survey followed by data analysis and representation. An example of algorithmic thinking is a Google search or creating a PowerPoint quiz with different pathways for wrong or correct answers. SparkView and Capstone software now include Blockly coding. Now you can support computer science standards while reinforcing science concepts and encouraging the computational thinking process. Let's share how you might do this in a classroom. You can start by choosing from our experiment library. For this example, let's focus on the pH of household chemicals. Here, your students start by investigating the pH of various liquids using the pH sensor. Here they gain knowledge of the pH scale and also tackle the deeper discussion on its importance and how it relates to the real world. We have developed Blockly extensions to support the science content, but now introduce coding. In this example, we provide the students with an initial set of code and ask them to replicate a program that would identify a base from the list of household chemicals they identified in the previous lab. We can further support computer science literacy by asking students what the importance of a loop is or what role conditionals and statements play in the programming process. Blockly provides numerical and text output capabilities so students can see data in real time. Next, we ask students to add to their initial code to create a program that would identify not only a base, but now acidic solutions and even the ability to identify a neutral substance. After students have investigated pH levels and created a basic coding program, you can challenge them to solve a real-world problem. For example, you just started working in a new factory that packages the various drinks that are shipped to schools for breakfast and lunch. Some of the drinks include milk, alkaline water, orange juice, sports drinks, and others. Can you help speed up the factory line by creating a program that will identify each of these beverages? This program will help in automation, making it easy to determine which cartons each drink should go into. This program is certainly more difficult as it requires the user to work with ranges, understand pH, and how to measure it. Again, students get both a numerical and text output. If the ranges are correct and the program is free of bugs, it will identify each drink on pH alone. So let's bring it back to the computational thinking process. In the Blockly extension for pH, we added a task. We asked the students to think about each step of the computational thinking process as they worked through all the activities and challenges. They were asked to document these in a chart for later reflection. Now we have students explicitly thinking about the process as well. To find this example and more lessons to support computational thinking, please visit our experiment library and search for Blockly. Thank you for joining us.